Very good morning, friends. Today we will see the next topic, that is kinetics of particles using impulse momentum principle. What is impulse momentum principle? So it will be in a body, the impulse is equal to change in its momentum. That is the impulse momentum principle. So suppose a body is moving, so the moving body will have a momentum. That is, momentum is nothing but mass into its velocity. That is nothing but momentum. So it will have a momentum, and for a while it will have a impulse. That is, after some time it will have a impulse. That is, force into time. If you multiply force into time, you will get an impulse. So the impulse momentum, what it says, the force into time is equal to change in its momentum. That is my impulse momentum. If in a problem the time is given after some time, what is the final velocity? If it is asked something like that, you can go for impulse momentum principle. So in impulse momentum principle, the eh, the methodology, the equation is impulse is equal to change in its momentum. The impulse it will be force into time is equal to final momentum minus initial momentum. Force you have to consider similar to the work energy principle. You have to consider in the direction of movement what are all the forces involved. That forces you have to add it, and that you have to use it to multiply with the time. You will get an impulse that is equal to final momentum, that is mvf, minus initial momentum mvi. Okay, so you have the impulse momentum principle. In that way you have to solve it. We will take a problem. In this problem you can see, in a slope a body A is there, and it body B is hanging, okay, through a pulley, frictionless pulley. So what is it asked? So initially the body is at rest and it starts moving upward. Okay. So after t time equal to 3 seconds, what is the final velocity? That is asked in this problem. The given data is mu equal to 0.15. Now what I have to do? I have to find out the body, first body's weight is given, that is 400 newton. Mass will be 400 by 9.81, it will be 40.775 kgs. Weight of the second body is 225 newton. Mass of the second body B is equal to 225 divided by 9.81, it will be 22.936 kgs. Right. So you have got these data. Now I have to solve it for impulse momentum principle. After 3 seconds, what is the final velocity? I have to find it out. So here you can resolve this body A, weight is acting downwards, vertically downwards. As we solve the slope problems, okay, so it is the body is on slope, so the weight of the body will be acting downwards. We will be resolving it into two components, that is horizontal vertical component equivalent to the normal reaction, and horizontal component will be its sine component. The vertical component will be 400, sorry, the vertical component will be 400 cos 20 degree. Horizontal component will be 400 sine 20 degrees. Okay. So apart from this, since the body is moving right side, there will be a frictional force in the left side, downward direction. That frictional force will be coefficient of friction into normal, that is 0.15 into n. 0.15 into n. So what is n here? So by resolving the normal forces, n is equal to downward force will be 400 cos 20. 400 cos, that will be 375.87 Newton. We have. Then what is the force along the movement direction? Along the movement direction. So there will be a force along the movement direction. You can see body B is hanging downward. So that will be 225. That will be 225. that 225 is positive, then minus frictional force, that is 0.15 n, then minus, there is a component of weight component, resolution of weight component, that is 400 sine 20. So if you substitute this n here, n value here, and you will be getting all constants, that force F will be 31.81 Newton. So this is the force. By using the impulse momentum principle, the first of all you have to find out the impulse. So impulse, how you will find out? That is force into time. So force into time, the force we have found already, that is 31.81 into 3 is the second. After 3 seconds, what is the impulse? That is 95.43 Newton seconds. So that is the impulse. So to find out the final velocity, what we have to use it, since VA and VB is equal to V. So both the body is tied together. So both body A and body B is having the same velocity, that is V. So impulse is equal to change in momentum, that is final momentum minus initial momentum. Final momentum will be MA plus MB, that is both the bodies weight mass, you have to add it. Both the bodies mass MA plus MB plus into VF, that is the final velocity, minus initial momentum, that is MA plus MB into V initial, that is velocity, initial velocity. Initial velocity, since it is 0, since it is 0, the whole term, initial momentum will be 0. So you will be having MA plus MB into VF alone is equal to impulse is 95.43 that you have in the left side. So from the 95.43 and the momentum, final momentum, I can find out the final velocity, that is 1.498 meter per second. This is how you have to solve the impulse momentum principle problems. So in this variety of impulse momentum principle problems, you will be given time to find out the final velocities. So in this kinetics problem, from the beginning we have seen the kinetics using Newton's second law. There you will be asked acceleration. In Newton's second law, you will be asked acceleration of the body. From the acceleration, using kinematics equation, you will be finding out the velocity, final velocity, initial velocity, you can find it out. But in the second variety of problem, that is work energy principle, we have found the final velocity using work energy principle. That is work done is equal to change in its kinetic energy. Using that equation, we have found the final velocity. So there the distance traveled will be given in work energy principle. In the third variety, kinetics of particle, using impulse momentum principle, it will given the time duration. After this time, what is the final velocity? So it will be asked. So in that case, you have to use impulse momentum principle. The impulse will be force into time is equal to momentum will be mass into velocity, that is the final momentum minus initial momentum. You can find out the final velocity. This is how you have to solve the kinetics problem. So with this we finish the kinetics problems. Thank you.